Okay, let's look at these IR unknown spectra and see if we can deduce a possible Lewis structure for the empirical formula or the chemical formula that's given. What we're going to do is use these IR stretching peaks to identify the organic functionality and then put together a Lewis structure based on that. The way I do this is always first figure out the nature of the hydrocarbon backbone. Are there single bonds? Is it completely saturated? Or is it unsaturated, meaning double bonds or triple bonds? That's always the first thing I look at. And if you remember, the easiest way to do that is to look and decide, is the carbon-hydrogen stretching seen at 2900 to the left or to the right of a line at 3000? If it's to the right, at 2900, that means that it is CH saturated, meaning single bonds. If there's a sharp peak to the left at 3100, or if that peak is in 3100, then that indicates that we have unsaturation, a double bond or a triple bond. In this case, I don't see anything. I can look up for justification by looking for peaks at a sharp peak at 2300, which I don't see, or a sharp peak at 1600, which again I don't see. So I'm pretty safe in assuming that this is all saturated hydrocarbon. And I have the CC single bond at 1400. And the CH from the saturation. So I know that I have an alkane here. Now I'm going to look for what is the oxygen functionality. I have two oxygens that I have to assign. These should be fairly obvious. I have the big peak at 1700 reciprocal centimeters, which corresponds to the carbonyl, and I have a fairly big peak at 1200, which corresponds to an ether. So the oxygen is both carbonyl and an ether. What we have to do is put that together in a molecule with 4 carbons that all has single bonds between the carbons. So if I draw a Lewis structure, I can come up with this structure, which is an ester, incorporating both the ether and the carbonyl. As I told you before, sometimes if you have an ester, you can see a peak at 3500, which suggests a ester is in that molecule. If we look at the second compound, we can go back and do the same thing, and I can see that there's maybe the 2900 peak peeking out of that big peak there, and there really is nothing at 2300 or 1600 which suggests this is anything other than a saturated system. So I have my 2900 peak. But the real clue to this structure is this big broad peak here, starting here, ending here. It can only mean one thing, and that is that this is a carboxylic acid. That OH stretch can only come about and be that wide if it's a carboxylic acid. And then here's the carbonyl. So I'm fairly safe in saying that this is a saturated carboxylic acid. and I can identify all of the peaks. There's a CC single bond peak. I can assign this to the CO peak, but you understand with resonance that's going to be an oddly shaped peak. The 1700 peak, of course, is the C double bond O. Once again, if we start this next one, I can see a peak at 3100. Fine, I'll cover it up. And a peak at 2900. Peaks at 1600 and 1400 indicate to me that there is unsaturation with carbon-carbon double bonds present. So I have those peaks. The oxygen functionality, I only have one oxygen to consider. And here is my peak at 3400, which says OH of an alcohol. And then I have a peak at 1100, which says this is an unsaturated alcohol. So I have all my peaks listed. Then I can go through and draw a potential structure. Give myself a little more space here. If you work on it, the only way to incorporate that many carbons and that many hydrogens is to make a benzene ring. So we have unsaturation, saturation, and the alcohol group. For the next compound, I see peaks that are extending out over 3100 and 2900. I see peaks here and here. If I walk through this compound, the two oxygens are once again at 1700 for the carbonyl, 1200 for the ether. I have indications of unsaturation. So once again, I have a benzene ring. And to incorporate both the carbonyl and the ether, I can make that an ester. And once again, check that that little peak is there, indicating that I'm probably right on the ester. This will be continued in the next video.